Hey guys, welcome to DSA-n-Design. Today we will take a look at what is binary search, right? Binary search is one of the very famous searching algorithm, and it is famous because it works in a very efficient manner, right? When we talk about time complexity, right? So let's try to understand first what is the scenario when we use the binary search, right? We can't use the binary search in every scenario, but let's try to understand first, right? So I'll just take an example and I'll tell you how exactly we can do a searching, right? So since this is for a searching algorithm, what I will do is I will take an example, right? So example can be, let's say I take an array, right? Array could be having value 2, 4, 6, 8, 12 and 40. All right. Now I want to actually find a element which is, for example, 12, right? And if I find, right, if found, this element is found, I have to return basically index, right? Index of this particular element. So for example, in this case, the index number 0, 1, 2, 3, 4, 5. In this case, I will actually return 4. All right. If not found, not found, in this case, I have to simply return what? I have to return -1, guys. Okay. In case I don't find, I will just simply return -1. All right. So, for example, if I can just say that if e equal to 30, right? I don't have 30 in my array, right? So, in that case, I will simply return -1. All right. Hopefully, you got this, right? So, this is what exactly we want to do. But there are two ways to do this basically. One is I can actually just uh, traverse this particular entire array, and the moment I find it, I will just return the index of this particular index. Otherwise, I will be exhausted with searching entire search, right? This entire array. At the end, I will just return -1, right? So if I can just show you how actually, so this is called linear search, right? Because we are actually linearly searching each and every kind of element in the array, right? So for example, the simple code that I can say is I can just run a for loop. I can say int I equal to 0, right? I less than n is basically my total number of element plus plus, and then I can say if array of I equal to e, right? Then I have to say I return return I basically, right? Correct? So I will run until this. Any point of time, if I find uh, this particular element, right, I will just return I. Otherwise, what I will say, I will go outside this here, right, outside the for loop. I will just return -1, right? Simple. This is what exactly we have to do, right? So this is called the linear search, right? This is my linear search. Agree? My linear search. However, if I basically uh, in this case, what is happening? If you look at it, right? If my array element, the last element, right? For example, in this case, if my e is basically, in this case, my e is actually 40. In this case, what I will do, I have to travel all these elements basically, right? So in this case, how many elements are there? There are 6 elements. I have to actually travel all the 6 elements, right? So entire array, which means the time complexity of this particular algorithm is order of n, right? But um, I want this particular algorithm, I want some other algorithm which can be, which can work in better manner, right? Because here I see my data is in sorted order, right? So I'm talking about the sorted order, that my data is in sorted order, but I want something very efficient algorithm. I don't want to go and find each and every element, and it's basically making my time complexity order of n, right? It is very simple, right? So what I will do is I will discuss something about binary search. Okay, so what is binary search? Let's try to understand, guys. So binary, basically you say binary is like 2, right? It's basically 2, right? So binary search, how it works, I'll tell you. Binary search is basically the algorithm which works in which works in much faster manner. It works in log base 2n. This is the time complexity for binary search. That's why it's very famous, right? So here we have looked at it, right? So we have actually we have to traverse each of this element, but now we will look at it how exactly we can use the binary search and we can perform it in a better manner, right? We can search it in a better manner. So let me just do one thing. Let me take this particular array, right? So that I can just take it. Okay, maybe I can just write it 2 4 6 8 12 40, right? Let me write it here. So for example, my array is here. My array is 2 4 6 8 12 and 20, maybe 20. Okay, that's fine, no worries, right? 30 in fact, I guess it's 30. It's okay, doesn't matter, right? Now this is my index, right? So 0 1 2 3 4 and this is 5, correct? Now let's say I want to search basically 30 in this case. So in linear search, what will happen? I will actually traverse each of this element and compare it, right? So in this case, the worst, I will actually be able to find this particular element at the end, right? Which means I have to traverse entire array, right? Now in binary search, what binary search is, that let's do one thing. Let's try to find out the middle of the element, right? Rather than comparing the first element, let's compare the middle element first and see that actually whether my element is lesser or bigger, right? In this case, for example, what is the middle element in this case? 0 and 5, right? The starting index is 0 and 5. So 0 plus 5 divided by 2. Basically what we are going to do is we are going to say left are low and high. Okay, this is low pointer, this is high pointer. So basically index 0 plus 5, right, which is actually 2, correct? 5 by 2 actually 2.5, which is 2, right? 2 is where this is here basically, correct? This is my 2. Now it says that okay, compare this particular middle element, right? M is what, right? M is L plus high, low plus high by 2, right? This is what, and compare this particular element which is this 2, right? 6 basically. So when I compare E with 6, I find that my E is bigger, right? In that case, what I say is I will actually discard entire this side of it, right? Because it is in sorted order. So my element is 30, which is bigger than this 6, right? There is no chance that I will find my element in the left side because this entire array is in sorted manner, right? So after 6, left hand side, all the numbers will be lesser only, right? So that's why there is no point of searching left hand side, including this also, because it says that 6 is less than 30, right? So 6 is also not applicable. So there is chance that I can actually find in the right half of it, right? Which means I will actually set my L, which is low, again here. Okay, let my high be here only, again low will be here. Now again what I will do, I will again do that L plus H by 2. So L is what, guys? L is basically pointing to 3 index, plus H is what, 5, right? Divide by 2. So this is this time how much? 8. So it's basically 4, right? 8 by 2 equal to 4. 4, index number 4. So we are actually here. You see here. Now this time I will compare that whether my array of middle, correct? Array of middle is, what is the position, right? So I find that array of middle is still less than 30, correct? Because array of middle is 12, no? So this is still less than 30. So what I will see is, okay, in this case, now again the same scenario, my left, my means I will not find in the left side of it, right? This is of no use. So I will discard this. I'll only move right hand side. So I said that, okay, including this middle position also, right? So I will actually start my low. Let my high be there only. I will reset my low to this particular location. Now I find, okay, my low is 5 and high is 5. Again I will check low and 5 and high is 5, which means 5 plus 5 by 2, which is actually 5. Alright. Now I will check what is my array of M. Array of M. Now this point of time I say array of M equal to 30, and also my E. which is element that I'm going to search, it's also equal to. Then I say I found it, and I will simply return M. What is M? Which is basically index numbers, this one, right? So hopefully you got it, right? So this is what the algorithm says, right? So let me do one thing. Let me try to code it, and then I think we'll get better idea basically, right? So this is the same concept that we are going to use it there, but let me do in coding, right? Let me do it. So I'll just create a class. I'll say this is my binary search. All right. All right, guys. Now let me create main. All right. Before that, what I will do is I will just put this same array, right? So I'll just in the main, I'll just say 2, 4, 6, 8, 12, and 30 maybe. Yeah, this is the same array that I'm taking, and I'll say int e or okay, that's fine. The searching element e, right? I'm just going to search 30 in this case. Okay. Now, what I will do is I will say that int answer equal to, I will just write a function binary search, and here, okay, maybe I can write it binary search. This is my function. I'll just pass array and e, these two items. Okay. Now let me create this particular. Let me develop this. This will actually return integer, which means index, right? What index this particular search I am able to find. So I'll say array int e. All right, make sense, guys? Let's go there. Now what I said is I will actually first I will actually get the low and high, right? So low is basically what I will, let me get the first size, right? So array ka size, array dot length, all right, int l equal to 0, and int r, not r, high basically. I'll say high equal to n minus 1, right? This is my l, low. Got it? Now what I said is I will actually I'll traverse, actually I'll put a condition until my left is less than or equal to high. Okay, the moment my, my low is greater than high, I'll come out of this loop and I'll return minus 1. Okay, but until and unless, okay, so what I will say, since if I do not, I am just writing it, I'll just do a dry run quickly and I'll show you also. Right now what I will say is, first of all I will just get the mid of it, right? L plus I divide by 2, right? And now here what I will do, I'll say if array of m, what I'm going to do, I'm going to check whether my array of m equal to e. If this is the case, then I will simply return m, because I found this element, right? Else if there are two conditions. First, array of m, okay, if array of m is less than e, which means my element is bigger, so I will not find in the left hand side. So what I will do, I will actually set my l equal to m plus 1. Okay, that's what we did. No, I will actually set my l after m. Okay, means whatever was the middle, right? Else I'll just say high will be m minus 1. Okay, which means I actually traverse to the right hand side. Means every time I am discarding the first half of the basically search space, right? That is what we are doing. Now let's try to see if yes, makes sense, guys. Okay, let's try to okay, I have to actually, this is, I have to make it static, I guess, right? That's why it's giving error. Okay, static. All right. Let me try to run it and show you basically what I'm getting, right? So in this case, I should be getting 0, 1, 2, 0, 1, 2, 3, 4, 5. I think 5 I should get because it is 30 is on the fifth index, right? Let me try to run it. Is it not running? Okay. Oh, sorry. I have to print it, no, guys. How I'll get it? Okay. I'll just print the answer, guys. That's it, right? Let's run it. and see what we get. We should actually get 5. See, we are getting 5. Let's see if I'm just trying to search 23. We don't have 23 here, so I should get actually what? I should get -1. Let's see if we are getting. Yeah, we are getting it, right? Let's try to search maybe 4, right? I should be getting index number 1 because this is 0 and 1, right? So I should be getting 1. We are getting 1, right? See, this is working. So now I'll show you, right? So this is very efficient algorithm. That's why I'm saying if I can just dry run on this one, right? What exactly we are doing it. You see here, right? In this code base, let's say, okay? What I will do is, let's say, um, my in this case, no? Hmm, correct. Just give me a second, guys. Okay, so here what we are doing is we are every time we are actually calculating the middle of it. So if I can just run it here, maybe one more time probably with the same set, I think it doesn't make much of a difference, but quickly maybe I think it will give you more idea for you, right? So if I can just show you one more time, right, based on the code, right? So if I will take some other number, maybe right this time, okay? Okay, why it's not. Is it okay? Fine. Now let's say I want to do 2, 4, 8, and 10. Okay, this is my array, and this is my index 0, 1, 2, 3. What I want to search is my search element is, let's say, 8. Correct. Now in this case, what I will say, I'll just find mid actually. So in the step 1, right? I'll say mid. Mid is what, guys? This is uh, this is L and this is H. Correct. So L plus H by 2, which is 0 plus 3 by 2. Actually, 3 by 2 equal to 1. Correct. 1.5 or something, but it's one numerical number, right? Which is basically this. So middle is basically this one. Now, once I get this middle, what I'm going to check actually, I'm going to check whether array of middle, right, is equal to what? Is equal to E or not. If it is, then I will simply return M. If it is not, so in this case, what is happening? Let's see. Array of M, array of M is 4, right? 4, and E is this one. So array of M is less than E basically. Correct. Array of M is less than E. In this case, what I said is my array, the desired element is at the right hand side. So what I will do, I will actually discard this entire space basically. I will discard this entire space. I will set my L to this particular position, okay, which is M plus 1, right? So in this case, I have to just set my L equal to M plus 1. That's it. Now my high and L is here. My high is now this time what? 2, and sorry, low is 2 and high is 3 by 2. Again, what? 5 by 2 equal to 2, guys. So 2 is basically where? This is my 2, right? So this is my 2, which is my M also. Correct. Now I will check what is if array of M equal to E. This time I found that, okay, array of M equal to 8 and E is also 8. Then I will return M basically, right? Which is right actually. So return M means I will actually return index number 2. Got it? So I think this is what I try to give you explanation, guys. If you still have any doubt, you'll just let me know. I might I might do a little longer video for you to, explain it in much detail. I know that there is some constraint of the time, so that's why it's not very easy to, explain this kind of algorithm. It obviously takes time. But if you are really interested, do comment in this video. I will be happy to do one video which will be in much detailed fashion, right? But I think hopefully this is giving you idea, right, how actually binary search works, right? And in this case, I will not discuss too much about the time complexity, but it's order of, as I said, right, order of log n base 2, correct? That's how it is, because half of the space we are actually discarding, right? If I can quickly just show you like how exactly we are talking, why we are saying basically it's like a time complexity. So First, let's say I have this much, right? So this is my low, this is high. Every time what is happening, I am actually, let's say, finding middle, right? In this case, I am, so this is, let's say, n elements, right? N elements total. Now I got this middle element, right? Now I am actually discarding either this side or this side, correct? Half of the element are getting discarded every time, right? So in the second iteration, let's say if I discarded left hand side, so my elements will be n by 2. Next time I have to search only n by 2, right? Now again, in the next one I have to again discard half of it, right? So either this one or this one. Let's say this time discarding this. So the total element will be again n by 2 by 1 by 2, correct? N by 4. The next time n by 8, right? So if I can just add it, n plus n by 2 plus n by 4 plus n by 8, right? Like this, correct? Until we go 1. So what will be the time complexity for this, guys? It will be order of log base 2n, right? We know that how we basically get this, right? If you add it, you will be getting log of n base 2, right? So this is how it is arriving. All right. So that's all for this video, guys. I hope that this is really making sense. And do let me know if you want me to, explain much, little more detail about it, right? I know that this is sufficient, but if it is at all any question, let me know. All right. Thanks for watching, and I'll see you soon with the next video. Until then, happy learning. God bless you. Bye.